right before page 1, they have the steps for graphing a rational function. Now, we've already done this. The very first thing that we're always going to do is look at our non-permissible values to determine whether or not they're holes or they're vertical asymptotes. After we've determined that, we then find out if there's any horizontal or oblique asymptotes. I like to do the intercepts third. And the intercepts third, and I basically for 4, this one is just basically graphing. So 3 and 4 kind of go together. You find some points, you graph them. And I would say you're going to find the intercepts and any other points. You might need more points than just the intercepts to graph it. So we're going to see what that looks like over the next 3 or 4 examples. So example 1. Step 0, before you even start, is you will always factor things completely. So on the top here, this factors nicely to be x minus 1, x minus 4. And the fact that the bottom says 1 minus x, you've seen this a fair bit already. You see there's an x minus 1 on the top and a 1 minus x on the bottom. Not quite the same, but if we factor out a negative, they are the same. So in this case, this would simplify. And writing the simplified equation leaves us with x minus 4 over a negative 1. Is everybody okay that this is the same as negative x plus 4? So step 1. Do we have any non-permissible values? Yes. Even though it's simplified, we still have a non-permissible value. X cannot equal 1. But in this situation, it's going to be, because it's simplified, a hole. How do I know that that hole is at 1, 3? Because I'm the teacher, I looked at the answer key beforehand. Perfect. Well, the non-permissible value is 1, so that's where the x coordinate comes from. Where do I get that value of 3 from? Right? Once we simplify our equation, that's going to be a straight line. And on that straight line, when x is equal to 1, y is equal to 3. So if you have a hole, you can plug the non-permissible value into the simplified equation to find the coordinates of that hole. Anytime that your non-permissible value simplifies and goes away, that's telling you it's going to be a hole. And then once you know that it is a hole, you take the simplified equation, which is right here, negative x plus 4, plug in x is 1, and you get y is 3. Now, for step 2, the horizontal asymptote and oblique asymptote and graphing, you always graph after your equation has been simplified. So, which is a little bit different than a lot of things you do in math. A lot of things you do in math, they say, always look at your original equation, always look at your original equation. But once you find out that something has a hole, well, all that it's going to mean is you're going to graph the new equation and just add the hole to it. Because this is a line. A line has no holes in it. So this graph is exactly the same as this graph with that added hole. So we can skip and go right to the graphing in a question like this. This one will have no horizontal asymptotes, no oblique asymptotes, because you've just got negative x plus 4. So that has a y-intercept of 4, a slope of negative 1. We can add the hole, which is right here, 1, 3. We know that it goes through 0, 4. Slope of negative 1. This is what your graph will look like. And that's it. Now what makes these ones hard is you feel like, oh, if I'm going through the steps, I don't have any horizontal asymptotes or oblique asymptotes. So it can sometimes throw you off. But whenever you have a hole, you simplify your equation, and then you graph whatever you get after that. And if what you get after that is something simple, like this is a straight line, I could give you a parabola with a hole in it, right? Then you just graph the simplified part and add the hole. Okay, questions for this one are number 3.